This is the Amp Hour Podcast, released November 8th, 2020, episode 516. Thermions aren't a thing.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
What's up, nerd?
Oh, some stuff in the US.
Don't know what you're talking about. No idea.
I know.
Yeah.
It's almost over. We'll see.
Excellent. All right. Let's talk some electronics, shall we?
Yeah, exactly. I have been diving into work to try and distract myself, and luckily, it has been bountiful. So lots of work to do.
Yep.
I don't know if I've mentioned on the show before, but I've been working on like Nordic parts a bunch. Maybe I've mentioned it.
I'm sure you've mentioned it.
Yeah. So I do have one. I have a Nordic part on the ABC board, which is that board I made for the course, and that's the cellular board.
Yep.
But then I've been working on a little bit otherwise for one other project and then a client project and whatever else. What's interesting is I finally got like the Bluetooth bootloading to work.
Yep.
Have you ever done that? Did you do that with the meter? I have your meter here, but I don't know if it loads firmware over the Bluetooth.
No, it doesn't. No, we deliberately didn't do that because it was exceedingly hard, they said, to do anything over the Bluetooth like that. So, yep.
Oh, okay.
Unfortunately. Yes, it was originally, yes, we wanted to do load the firmware over the Bluetooth and also upload from the SD card as well from the Bluetooth. And you could have actually almost tied those two together, but it was, they just deemed it, no, it was like, it's not worth our effort. It's not worth our time investment in that. So
I would actually say it is worth it. So I have been shocked at how interesting it is to have that capability now, because now I can ship off firmware to someone and it's literally like, hey, open this app, upload it, you're good to go. It blinks a little bit and then it's like,
yeah, but we already had an SD card in the product.
No doubt.
SD card firmware uploading. So
I'm not questioning the practice. I'm just saying that no,
of course there's benefits.
I have found it to be very interestingly.
Yes.
It's very different for me because people that do regular software updates things and have bootloader chains that are very well known, they're like, yeah, of course that you do that. But for me, it's very different. I think the big downside is that it just takes up a lot more memory, so
oh yeah, it does.
Yeah. So it's I've got the 512K part and a bunch of that. So I think maybe 60K of that is the actual Bluetooth soft device because it's a Nordic part. And then, and then you have to have pretty much double the rest of that. So basically I have 440, I think, available, 440K available. You can only really build it into 220. You only get about 200K for your actual program then. So
right.
Luckily, I write very simple programs.
Geez, when I was a boy, I have to link in my 1K video of what,
that's right.
What you can do in 1K, And you remember the 1K contest,
Yeah, exactly. Yeah.
And it's, but the thing is, a lot of parts, I don't know about the Nordic ones, a lot of parts will only have they'll have a separate segregated section, a safe area of bootloader memory, and that will be limited. It might be, 2K or something like that. It might be a limited, you can't just extend it to...
For the bootloader itself, you mean?
Yeah.
Oh, yeah. The bootloader is at the top of the memory stack.
Oh, so you're saying don't put the Bluetooth routines in the... No, but it has to be in the bootloader, so it's fully protected. So even if you goof it up completely, you can still recover via the Bluetooth. So it's all got to be in that protected memory space.
You mean the actual Bluetooth capability?
Yes, the Bluetooth
no,
code.
Because the Bluetooth stuff is weird. So Nordic does it where it's a binary basically, and I mean they're all binaries, but basically it's there's an API to this this just chunk of memory, and so basically you have to preserve part of your flash and part of your RAM, and it's just going to run out of there. And people who know more about this stuff are just laughing at me right now. That's fine.
Yeah, right, of course.
But basically, that's kind of the bottom part. So that's basically 0x0 to like 0x2600 or 26,000. And so like that's basically just what the soft device is. And it's like basically every function that you might want to use on the Bluetooth side of things, it's in there. And then the bootloader is actually at the very, very top of the memory. So like whatever the
yeah, but both of those have to be protected memory spaces. Otherwise, you're going to Kamagutsa.
Yes, that's right. Yeah, I agree.
And well, that's what I'm saying. Some processors only have that a small amount of protected memory space.
Oh,
so you would not be able to fit Bluetooth in there.
Got it. Yeah. And it is a big Bluetooth thingy in there. Like that soft device is.
Oh yeah, it's a large build. Yeah.
Because it's basically like it's all or nothing. You basically use all you put in everything in the kitchen sink that Nordic offers you or nothing. Yep. And so I'm still getting my head around it, but like in the Zephyr stuff that I've been doing, it's like I think it's more selective on the build, because the idea is like I think they didn't want people to mess it up during the build, but I think they also didn't want to show their source code in the old way of doing things for Nordic. But like now I think there's actually like the whole stack is in there and available, and like you can selectively build what's in there. So you could shrink it down if you needed less stuff.
Okay.
I think.
Got it.
So yeah, it's interesting though. And so like, but now basically I have to like package up the firmware that I make then is like basically just offset. So it starts at the beginning of basically at the end. Sorry, it starts at the end of the Bluetooth memory area, and then it just runs like a normal program. So it's super cool. Firmware, Dave. Who knew?
One of the reasons also that we didn't do it in the multimeter is because ours wasn't a Bluetooth chipset; it was Bluetooth LE, which is actually quite a different beast. Bluetooth LE is much harder and much more inflexible, much less flexible than normal Bluetooth. So, yeah. Just beware, like Bluetooth LE does not support serial ports over Bluetooth, for example. You've got to kludge it. If you want to do that, you really have to kludge it.
Yeah, I don't know about that yet, but that is
you don't want to know. It's awful.
Yeah, you're saying because it's like low power and it would not be able to stream stuff back. Is that kind of the thinking?
Yeah, and it's designed to be ultra low power. Like Bluetooth is pretty low power, right? But Bluetooth LE is, yet another level down. So,
yeah. So I'm still learning a lot with it, to be honest. But I'm very excited about it. It's cool stuff, and like I said, the ability to like just kind of push updates is real nice. So
right. So yes, my pro tip there is don't use Bluetooth LE unless you absolutely have to use normal Bluetooth. So
I don't agree with that.
No, trust me.
Yeah?
Yes. It's a long, hard, expensive lesson learned, I can assure you. Bluetooth LE.
You guys used a module or you used a chip?
Yeah, we used a module. Oh God, it was the 112. What is it? The BLE 112? Am I right? Jeez, I can't remember. It's scarring.
Silicon Labs.
Yes, that's the Silicon Labs BLE 112.
The latest, it's Bluetooth 5, it says.
I think, that's, anyway, it's,
So were you guys just you were talking to it from another micro though, right? So like you have like STM32 on board and then you just kind of
that's right.
throw serial commands of this thing?
Yep.
Okay.
But, no, it wasn't that easy. Because as I said,
well, yeah, it sounds like it's not easy.
Bluetooth LE does not support proper serial implementation. We thought it did. And that's why we spent a huge amount of time, money, and effort trying to get it working. And it's a real kludge in the end.
Yeah.
You can get it to do it, but geez, it's just not as easy as it is on normal Bluetooth.
Got it.
Yep.
Yeah, isn't it crazy when some of those, so like, now thinking about it now, that like you would go back and tell yourself like, oh, well, look a little closer at that serial side of things. That's really going to be important, right?
We just took it for granted.
Well, but I mean, that happens all the time in designs, and like some things it's fine, right? It's like, it's a software fix, or change a resistor, or but some things are just, man, they're like so fundamental to like the architecture of your design. It's just like, that's going to change everything,
Exactly.
So, yeah.
Yep. Beware. The other thing is, USB power delivery. You've heard me crap on about that before.
Well, of course. Yeah.
You think that's easy. No, It's not. It's a nightmare. It's an absolute design nightmare.
I have to feel that's getting better though. Like there's more chipsets that are out there for now, right?
It probably is. Yeah. Yeah, and once again, there's that large stack problem. Yes,
Sure.
ST offer a a Bluetooth offer a power delivery system, but it's like,
Dave, it's all the same.
but it's like a couple of $100K or something, right? And it's like all or nothing. You've got to use the whole lot.
$100K or
No, as in 100K of memory just
okay.
for implementing. It's insane. Right? It's just, it's just crazy. So you can't use a small, simple micro to do USB power delivery.
Yeah.
It's just,
Yeah, I think that's one thing I've been thinking about too. Is just like so I think that being a later adopter, as is my goal in life, you get benefits of like, so as die shrinks happen or as firmware gets more, like the Bluetooth. I think the soft device that I'm using is like the version 7.0 or 7.1 or something like that. It's like very, very mature, at least in terms of the Nordic stuff. And it's like I'm benefiting from all of the heartache that happened and heartburn that happened from people that were using the 1.0 standard. And I've heard people complaining about it, but now it's just gotten so mature. It's like, oh yeah, it's just a thing now. And like, and it was still hard for me, but me as a solo engineer, I can actually implement it versus needing a team of like 6 people and like, long nights in the lab to try and get this thing working. I think maybe with the power delivery stuff too, it's like more chipsets are coming out. And so it's going to get easier to do that sort of thing, but it's just a matter of maybe buying a more integrated part or, reevaluating, like, like it becomes a system design problem. And like you are not, for the stuff you work on, you're not going to go back and rip everything up, but someone who's starting a new design might benefit from the new chipset and just leapfrog a little bit in that way,
Yep. Agreed.
Sucks. Yeah. Electronics.
Can we talk about something vastly simpler and to me, vastly more exciting?
Okay.
I just discovered this. Sorry, I don't have the name of the person who alerted me to these things, but it's probably going to be today's video that I shoot if I get off my ass and do it. These are very exciting. I'm so super excited about this, and I'm a total nerd because it's
burying the lead, folks. Burying the lead.
It's a thermal jumper.
There it is.
What is a thermal jumper, I hear you say?
Yes.
Apparently these are fairly new, hence why I've never heard of them before. Like the person who sent it to me said he did a bit of research and said, yeah, it looks like they've only come out in the last year or something. They're available from at least 2 manufacturers, Vishay and a company I've never heard of called American Technical Ceramics, ATC.
Yeah, that's not a great name.
ATC, but it's the engineer's choice. That's their they've stolen the Tick single.
A name that only an engineer could love. How about that?
I'll send you the linky to the ATC one because you won't have that. So there you go.
Okay.
What these are, right? I've done a video which we'll have to link in on doing thermal design for SMD parts, right? And it's actually surprisingly tricky and hard. Right? If you want to get heat out of surface mount part, well, let's look at through-hole parts, right? If you've got your TO220 package, right? Obviously, people have been doing this for 50 years, right?
Better screw that sucker down to a heatsink, right?
Screw that sucker down to a heatsink with some thermal paste, right? No worries, right?
Bob's your uncle. Bob it on.
Right? But try to get heat out of a modern, SMD power transistor. Right? In a, whatever your favorite SMD package is, right? Or try and get it out of a motor driver chip with a big thermal, pad on the bottom and stuff like that. Now, you might think, oh, okay, no, you just tie it to the ground plane. Well, a lot of these have to be isolated, right? A lot of these things they're not connected to the ground. So you can't just connect it to the ground plane. And you might think, oh, well, I can just via stitch it down to a big, PCB mounted, thermal pad, and then maybe put one of those surface mount heat sinks on top.
Right?
Have a floating pad, effectively. Yeah, a floating pad. But hey, bingo, you've just killed your PCB layout room, right? Or you need to go to a 6-layer board because you've already got 4 layers, 2 for your power, 1 power, ground, and 2 routing layers, and then what, you want to add another 2 just for a heatsink? Okay, but it's going to cost you more. It might be cheaper to go to one of those SMD, one of those pick and place SMD heatsinks that you can put down, right? They're available in various scenarios and stuff like that. But the whole idea is when you go to SMD, right, you want to do everything SMD. Right? That is the holy grail. Right. And you don't want to say, oh, let's mix some through-hole parts in there, and I'll use a big TO220 because I need to screw it into my heatsink, right? No, you want everything pick and place.
How much could it possibly cost to just have some hand-placed, hand soldered and or wave soldered things?
It's just, it's going to be vastly easier, cheaper, and simpler to have everything SMD. But as I said, you've got the problem with getting heat out of SMD parts. So, ta-da! These new magic thermal jumpers, they look like resistors or surface mount resistors, available in different packages, big, fat, wide ones, by the way. People argue over whether width or length is better. When it comes to thermal, I'm telling you, width. You want width, okay? Because it's...
I mean, wouldn't it just be the same surface area or no? It's not.
No, because it's got a longer path. It's got a longer path. So you want a wider, shorter path than a long, even if it's the same surface area. Because if you do the electrical analogy.
Yeah, I guess if you take that to extremes, right?
Well,
yeah, if you had like a really long wire, that would be a much worse. Like instead
extra
of like
resistance, which in this case translates into the thermal equivalent, which is extra thermal conductance, right? So you get a higher thermal resistance, right? So more power dissipated. No, you want a fatter, wider, shorter part. Anyway, they're surface mount parts. You can just, pick and place. They come on a reel. You can buy them on a reel. They just pick and place and they drop down.
They look like resistors, honestly. Like
they look like resistors, yeah. But they're actually they're made of a, what's the, hang on. I'll get you what they're made of in a sec.
AIN, is that it? No. Thermally conductive AIN substrate. I don't know what that means.
Yes, it's an aluminium nitride. Substrate materials. And aluminium
that's an L. Okay, ALN.
Yep. Yes, aluminium
lowercase
nitride.
L gets you every time.
Right. So they're made out of aluminium nitride, and they're thermally conductive. But the beautiful thing is that they're electrically isolated, right? Yeah. So that you can like literally put these right next to the pad that you want to get out. Say you got a big thermal SMD package, you can put this right next to it, and bingo, it's a low thermal conductivity path through to, then you can get it out to a ground. So then you can connect it to your ground plane, right? Because you've already got, usually you're going for a 4-layer board these days for any sort of like complicated design. So you've already got that big ground and power plane in there. You can use that as your heatsink. And that's what's so exciting about these things, but it's got to be electrically isolated. So that's what these things do.
You still want to send it to your heatsink. You still want to send it to your ground plane. You want to use all the copper, but you don't want to send the electrons, you're saying.
That's right. You don't want to send the electrons. You want to send the heat.
You want to send your thermions.
Your thermions. I'm sure that's a legitimate physics word.
Yeah, sure.
Thermions.
If not, it is now.
And the other thing is that they're very low capacitance. We're talking like, 0.1 puff or something like that, which is important if you've got like high switching stuff, right? So if you've got big switching power transistors, right, operating at, a meg or something like that, you don't want high capacitive parts coupled onto there either. So that can be a big deal. So I'm very excited about these things.
Can you try and paint a picture of what this looks like though? So like, okay, so like what
picture of what it looks like?
Yeah. So like, okay, so you're going, no, I get that. That actually, there's like a thermal picture. I meant like, so you have like a thing that looks like a 0603 resistor or equivalent, right? That is directly touching another component on one of the leads. Is that the idea? Or is it just touching an area, like an isolated area, and then taking that to the ground plane?
The whole idea is that, let's say you wanted to get heat out of an SMD resistor, right? Let's say you had a power resistor or something. You wanted to get heat out of it.
So like a sense resistor of like a motor driver. Okay.
Yes, a current sense resistor or something, and at maximum current you design it, and it might be a 1 watt power dissipation, right? It might be, a big ass power resistor, right?
Right, and it's got a thermal coefficient, and that might change the resistance, and yada, yada, yada.
Yep. So what you want to do is actually, here's where you have to change the footprint. Well, you don't have to, but anyway. So you extend the footprint out so that the footprint of the resistor, so that then you connect the thermal resistor, right? Let's call it the thermal jumper. Sorry, you connect the thermal jumper directly to the pad of the resistor, right? So you essentially solder them both onto the same pad. You can use separate pads and then join them with a gigantic thick track, right?
Mm-hmm.
And then it's going to suck all of the thermions out of the, I love that word, out of the resistor. And you could do it on both sides. You could do it on both pads.
That's what I was really wondering. So it would, like when I guess that's the thing that I was confused about, because when you think about like a heat, so say we're using that same, like a nice big sense resistor, 0.01 ohms, and it's still dumping a ton of heat or something like that. Normally, if you're going to heat sink that, you would make a physical contact with the heat sink and then maybe some thermal paste, and then that is the conductor, like through the actual package of the resistor. It sounds like now it's drawing it through the pads though.
It's got to go through the pad, whether or not that is a regular component pad, or whether or not it's a power pad on the bottom of the chip, or whatever it is. Yeah.
So it could be like maybe a small. So say that the sense resistor had an actual mounting element to a thermal pad that's not tied to a much bigger ground plane.
Yep.
It might have that as, so this would maybe be the bridge from that small thermal pad.
That's
where
right.
It's just contacting the package of it versus, okay. All right. So that's where I was getting confused. Yep. But that's super cool.
But obviously this is not as good as going directly via vias down to your ground. If you've got a big thermal pad, right, and you want to go down to your ground plate, this is where you need isolation, right? If you need, this is the key part about this product, is it's isolated.
Yeah. And what's the volt? Is it like super high voltage too, or no?
I'm not sure about the standoff voltage. That'll depend on the package.
Yeah.
Oh yeah, no, 1.5 kV AC RMS.
Oh yeah, I guess you're right. Good. That would depend on the creepage and clearance then.
Yeah,
of this specific part, right?
Yeah, but the actual part itself is 1.5 kilovolts. So.
Or would it be the breakdown of the material internally?
I don't know. It just says. This is the dielectric, so that's internal. That's by definition the internal. So it says greater than 1.5 kilovolts.
Yeah, because at some voltage, everything starts to break down, right? I mean, so
everything breaks down given enough voltage.
Yeah.
Oh, by the way, the term thermion is real. By the way,
is it? Oh,
yes,
okay.
yes.
Well,
it just occurred to me. Thermionic emission is a thing. It's it's like a valve thing. Thermionic emission. It's like elements.
Sure.
Anyway, so we absolutely butchered that.
Well, we need a new word then, but I still like thermion.
All right. Yep.
Have I ever mentioned the Hot Air Rises and Heat Sinks by Tony Cordoban?
Is it a book?
It's a book. It's a book. Sorry.
Oh, I love the title. That's just
it's actually it's like really cheeky. Like the whole book is written really cheeky.
I see. Is it about heat sinks? Because if it's not,
it's about it's basically like the front page is like, or the front of the cover of the book is just like a picture of a thermal graph drawn on a napkin with coffee and stuff, and
Oh, nice,
it's great,
yeah.
But it's all like it's very, what's it called? It's told like a story, the whole thing. So it's very narrative in that way.
Oh, that sounds
it's
great.
cool.
I might get that.
Yeah, you'd probably like it.
Yes,
it's a
unlike
good book.
The usual self-help recommendations you give each week.
Oh, sorry, I thought you were going to say unlike the usual equation-based books that are usually covering this topic. You know what, Dave? Whatever. Those also have stories.
No, it's just based on the title. I know it's going to be good.
Yeah.
So
you're judging a book by its cover.
Cover, absolutely, absolutely.
Yeah. Oh, and then the subtitle is "Everything You Know About Cooling Electronics Is Wrong." So it's very, very targeted.
Yep.
Anyways,
that's
a good one.
That sounds great.
Yeah.
Yep. Let's get that. All right. Maybe I can do a book review.
Oh boy, that'd be a first.
Yeah. No, technically it's not. I used to do book reviews back in the day.
Okay, Art of Electronics doesn't count, Dave. Art of Electronics doesn't count.
No, I used to do a book. I used to do book reviews when I first started my channel. Yep.
Yeah.
Yep. Used to be. I had multiple segments in the one video, and one of them was a book review. So anyway,
the good old days.
Anyway, I love these thermal jumpers. It's like I'm just losing count of the number of designs I can think of over the years where this would have come in so handy.
Yeah.
Really, somebody's going to jump in the comments and go, "Oh yeah, they've been around for a decade. I don't know about
Right,
that."
exactly.
But holy crap, I just learned about them, and I think they're the duck's guts.
Yeah.
So, and the price. Tell us the price, son, because I know you want to the in thousand of quantity. Hang on, just let me enter it into the digi keys here. 1,000 of quantity, about 36 cents a pop.
Well, that's
In
not bad.
1,000 quantity,
Yeah.
it's okay.
I mean, you're probably going to do not many of these, right? Unless you're having a huge board, in which case, or like a huge amount of heat in your board. But
well, yeah, as I said, just use one big fat wide one.
Yeah.
Or they jump up to 55 cents for the big fatties.
Okay.
So,
what's like one of your examples that you could think of?
Oh, getting out of like any power transistor design where I've had to in low profile stuff where normally you would sort of like have a thermal pad on top of the chip, for example. Right,
Yeah.
you would have a thermal pad on top of the chip, and then you'd have a heatsink wedged on top of that, or you'd have the case wedged on top of that. Right, so usually like a metal case or whatever.
Yeah, like a piece of metal just coming down and like clamping it.
But of course, getting heat out of your chip through the plastic case is pretty poor because the thermal conductivity of plastic is not great, right? So it's so you want to get it out from the pads, right? A lot of it comes out if you've got chips that's coming out via the bond wires because they're metal bond wires, right? And so the die heats up, the metal bond wires heat up, the pads heat up, right? Everything heats up, so. And if you've got power resistors, for example, it's like I've had to, I've done many times where I've had to put like little sort of like mini PCB heat sinks, like just large thermal pads, hooked onto my power resistors just to get the power, just to keep the temperature down. These
and then you wouldn't have, and then you're just dependent on radiation instead of like you don't have any like active cooling or anything like that, right?
No, it's a radiative thing usually, unless you got heat out the other way. I've even done designs where we've actually hermetically sealed packages where we actually inject them with a gas. So then a high thermally conductive gas, which then gets the heat out to the outside can and stuff like that.
Cool.
So that's very expensive, very specialized, small quantity stuff used in the military things, but it happens, when you need that specific requirement, then you go to town to do it, right? Doesn't matter how much it costs, right? Each package has to be hermetically sealed, filled with gas, then sealed, then tested, then gas tested that it doesn't leak, and has to be qualified that it can survive shock and vibration without leaking, without the gas leaking out, because if the gas leaks out, then your thermal conductivity goes to buggery, and the circuitry just cooks itself, because it can't get the heat out, right? And it's just, it's a nightmare. But there, as I said, like having that isolated those large thermal pads, it kills your PCB layout. It's just really annoying.
Right. It's like a keep out zone at that point, right? I mean, you just got to go around it. Yeah.
Yeah, it's just got to go around it. It ruins your layout density. And to be able to put in one of these small parts and then just get it isolated down to your ground plane, wow, ground or power, doesn't matter.
Yeah, right.
Wow, although like internal ground planes aren't the best heat sinks, right? Not exactly the most efficient because they're wedged between fiberglass, which is not
insulators.
Exactly thermally conductive, right?
Yeah.
And but in the military side of things, there's many advanced manufacturing technologies in PCB design, which a lot of people don't know about because you won't get it from your JLCs, your PCB waves, and your, all those, right?
Right. You're also going to be paying for it because that's
that
stuff
you can get high thermally conductive graphites embedded into your PCB material. You can get thermal water channels embedded into your PCB material.
Oh wow.
Thermal pipes. Like actual, not just like you can get water pipes embedded into your PCBs. You can get just copper conductors, like big copper rods embedded into the
like they do for like PC heat sinks and stuff like that. It's just pure copper like on top of a Intel chip kind of thing.
Yes, and but that'll be embedded into your PCB structure, and then you'll have these large copper tabs coming out the side, and then you could mount those onto large external heat sinks, and there's all sorts of advanced technology like that. And if you have to ask the price, you can't afford it.
That's right.
You know, but these things are real design requirements in the industry, right? That's why these technologies exist, because and this is just another neat little part. You know, it's not for everyone. As I said, if you can actually connect through to ground, well, you just put vias down to ground, right? No big deal. But if it has to be isolated, wow. Sorry, I'm very excited.
Yeah, no, it's great. I mean, are you doing any, are you doing power designs these days? I'm not doing.
This is not for a current design. No, I'm not.
Got it. Yeah.
No, I'm not doing a current design where, well, no, technically the micro supply, because in my video,
that's what I was thinking.
Which which will link in. One of them was trying to get. We designed a heatsink. Like a customized heatsink. I've done a video on that customized heatsink, and that had to be thermally isolated. You know, and it's like, yeah,
I can imagine from like a safety perspective as well. You know, it's good to be isolated, that kind of thing. So, yeah.
Oh yes, of course, yeah. Even if you could electrically connect it through to a heatsink, you may not want to. You know?
Right. Yep.
Because it may be a high voltage. Like, you know, if you're in a high voltage power amplifier or something, you don't want the heatsink to be tied to high voltage. You know, if you've got a big switch in, a big switch in, high voltage mains side switcher or something like that. You know, you may not want all the heat sinks to be live, you know? So
speaking of high voltage and things I don't want to be near, I did end up watching those videos we talked about last time, the 345 kilovolt and the 34.5 kilovolt. Yeah. My God. Like that is,
it's a different world.
Something. It is totally a different, I mean, like, I think the interesting thing to me about it was you're watching it. So if people don't remember, I'll link these videos back in again. So basically, it was a substation. This guy walking around just explaining what everything is. And what's interesting about it is he's talking through all these things, and I'm like, oh, transformer, like relay effectively. It's like all of these things that have these very, very common analogs that I'm like, oh yeah, I understand those. But these things are just monstrous. They're so big.
You do not understand these. You do not understand how you think you know how a relay works.
Well, I understand the concept. Maybe, how about this? I understand the block diagram, maybe. And,
of course.
Yeah, but the actual implementation, like a transformer that looks like that is nothing like I've ever seen. I mean, it's just...
No, because it's filled with oil because it needs to, it's like...
Yeah. Nothing I'm doing is filled with oil. Maybe me after like a plate of fries that I eat or something. Like I'm filled with oil, but that's about it.
A lot of people ask, like, where are jobs in the industry and stuff like that? Power, big industry power. That is because it's not sexy, right?
Yeah, that was the other interesting thing. That was tied to turbines, wind turbines, right? So that was like a substation for wind turbines.
Oh, yes, right. And it's just, there's so much call for people knowledgeable in, really high energy, high power stuff. You'll never be out of a job. Like, and they pay, serious money.
And the young engineers, they just go through them like, like matchsticks. So, they just burn up right away. So they're always looking for new ones. You got to keep filling that funnel, so that when Billy crossed the wires again. You're going to need a new intern.
I don't want to, definitely I'm not going to search for it and link it in, but I watched this video of this guy that was train surfing in India.
Oh God, no.
Yeah, no. Somebody filmed the whole thing and he stood up and you can guess the rest. My God.
Oh, thank you. Yeah. I mean, the internet's full of that kind of crap. I don't need that stuff.
You do not want to watch it.
Yeah.
Of what
I am interested in like so power delivery in terms of like, so grid modernization in general, right? I mean, like the US has some parts that are good, but like so much of it is just, there's so many old areas and like NIMBYism, you know that term? I'm sure you do in Australia, right?
NIMBYism?
Yeah, so it's an acronym for not in my backyard. So NIMBYism is basically like people who buy expensive properties and like, don't change anything. Don't let anyone, so it's like, that's a NIMBY.
No, don't build a nuclear reactor in my neighborhood.
Well, yeah,
build anywhere else. Just don't.
But like, it could even be like, don't upgrade infrastructure near me because I don't want you to change my sight lines out in the backyard.
Right, yeah,
like that kind of thing too. And like, that's problematic. So that's kind of a problem, but there are some areas that are modern, but like there's, like the logistics of doing that have got to be insane. I don't even know who would get on the show. If people have suggestions on who we would get on the show, and or if they know people, that would be very, very interesting, because that is so far afield from anything I've ever dealt with.
I tried to do that because just down the road from me here, like literally, I could probably walk there. Right, is the main control headquarters for the Eastern Australia energy grid.
Yeah.
Right, it's the main HQ where they control it. And I said, hey, I've got a big engineering channel. Can I come in?
I got a camera.
Yeah, I got a camera. And they went, no.
Yeah.
Even though I looked on their YouTube channel and they just let a whole bunch of students in to film, like a month before, but no.
TikTok and
Yeah. It's just,
Dave, you should have done some dancing, and then you could have gotten in.
Right. Okay. Anyway. Yeah. That's.
I mean, I think there are some like security risks there, and I get that. But I don't know how they would apply that unilaterally.
Gave them the opportunity to actually vet the footage before I actually released it, and they went, no, just
that's too bad.
Flat out no.
Yeah.
And they had a whole media department. Like I talked to the head of the media outreach department, and they said, no. It's like, well, what are you employed for?
I'm media. Yeah, right.
I don't understand why they have a job.
We talk to teletype operators and also weekly periodicals. People really seem to like those. Pamphlet writers.
Right. I'm sure they'd talk to Silicon Chip, if they wanted to write an article on it.
Oh, well, yeah. I mean, come on. Silicon Chip.
Anyway. Yeah, I tweeted it because there's fires in California again, right? And the grid went down, right?
Yes. So that's like a brownout situation. So like some of that is they actually take down the grid, I think, is a preparatory thing.
They do, but this was like an official announcement from the energy company running it or something.
PG&E is the one out there. Yeah.
Or somebody. It was, some sort of official, maybe a government thing. And they said, it's due to one of the reasons why it's going down, the grid's going down, is lack of maintenance. And I responded, and everyone's going, how do we fix this? How do we fix this? I'm going, well, hello. I don't even need to answer. The issues are caused by a lack of maintenance. How do we fix it?
I thought there's some punchline here other than the obvious.
No,
the obvious one is the punchline.
No.
Yes, it's maintenance is the answer, right? It is the problem and the answer. Yes. Yeah, no, it's true. I mean, it's
because you've seen that helicopter footage, right? Of the guys who actually clean the wires.
Oh, that stuff. Oh my God. Yeah.
Oh, that's insane. I'd love to do that. Just once.
Oh my God, no.
Wouldn't like to do it.
So Dave's talking about is basically it's a bunch of chainsaws that dangle down from a helicopter. They're not chainsaws. They're like rotating blades. I mean, it looks like it's just a death machine, really. And it just comes through and it just buzzes. No. I'm
not talking. They're very cool as well. Like they actually trim back, trees that are going to overgrow the power lines and stuff. No, I'm talking about the people who maintain the lines. They crawl out like a helicopter comes right up next to the line. They use a big stick to ground the, or to equalize the helicopter to the 3 to the 500 500,000 volt line, and then they crawl out of the helicopter onto the line. They put a harness on and they go along cleaning inspecting and maintaining the lines. Wow.
Yeah.
Yep. It's a piece of wire. You wouldn't think it'd need maintenance, but yeah, it does.
I mean, it's super high tensile and that's crazy. Yeah.
Yeah.
You would want to do that, really? I mean, is this like your adrenaline junkie thing?
Oh yeah, it'd be totally. Yeah, I'd love to do a helicopter drop onto a power line. That'd be fantastic.
Okay, well, that's so if we're taking a tally here, that's one person in the current conversation that would like to do that.
I'm sure it'd take a month of training just to get approval it's not something that you could just do. You'd have to take months and months of courses to to even be allowed to do that.
Have you ever heard that really bad country? Some people love it, sorry, but there's I am the lineman for the county. No?
Oh, yeah, I think I've heard that.
Oh, man. That's been like on playlists for me lately. And it's like so like, maybe it's John Denver or something like that, but I don't know. It's,
right, yeah.
It's real. Like I'm not my shtick, but it's funny that there's like popular culture around it too, I guess,
Right. Anyway, that's job of the week.
Yeah, sure. That's
no, it's seriously, job of the week, power, big industrial power, transmission.
I always had a lot of trouble
chunks.
with. I was what was I watching the other day? Maybe it was on the. I think maybe it was on that set of videos, but it was talking about like delta and Y configurations and stuff like that.
Yeah,
And
yeah.
it's made more sense over time. But I just had like flashbacks to like the fundamentals of engineering exam.
Oh,
And
yeah.
they love asking about that stuff.
Like, we had to, you had to learn all that, right? You had to learn your delta Y configurations and how to, do the calculations to transform between delta and Y and
Yeah.
all that sort of stuff. And it's like, yeah, I've never used it.
Right.
Like,
Yeah. Well, yeah, exactly. I mean, the
it's
people in
like,
the power industry, of course, do. But like, yeah, I
of
mean,
course, it's bread and butter.
it's
Use it every
pretty
day.
rare
But,
when I'm not plugging something in that's not
yep,
in the shape of a USB
yep.
plug.
No, as soon as you get to three phase, I'm actually confused. Like, huh?
Yeah.
Oh,
Yeah.
what?
Yep.
It's like,
Right.
yeah,
Right.
right.
Yeah, and it's all around us, though. Like it's got to be. So
Yeah, no, of course. Yeah, I just, if you don't work on that stuff, it's no
fades away.
DC, even AC. Like that's a bit confusing. Give me
Right.
DC, right?
Right. Exactly. Yeah. Yeah. Like I said, USB plugs, good for me. Thanks.
Right. Yeah.
Yeah. Well, just some of the scale difference too. I mean, like,
we're a bunch of wusses.
well, yeah. I mean, yeah. There's that, but like, just like the scale difference of like 345 kilovolts, and it's just like megawatts of power and all that stuff, and then and then I'm working on stuff on my bench that like if I scuff my feet too much and I don't
Microwatts,
put on,
nanowatts.
well, I don't put on my my wristband. I pop it
Yeah,
with
it's dead.
Yeah, it's gonzo. So yeah.
Yeah.
Speaking of bench, how did the move end up? I guess we
The
didn't get an
move
update on
is,
that.
and it's still not complete because there were a couple of last minute boxes that came out that I had to clear out like at the last minute, and they went here. I've yet to sort them, so there's still a few boxes on the ground. But I got my underbench storage.
Yeah, I saw
I've
that.
done a
There's
video on
about
that. Yep. It cost a pretty penny, but I for those who don't know, like you've no doubt seen, I keep most things in tubs. Right.
Yeah.
But tubs are annoying because they've got lids and they stack on top of each other. So to get something, and Murphy's law of tubs means that the thing you want is right at the back and right at the bottom tub. Right. So you got to take them all out and you got to, right. So it's annoying. So I thought, no, for like everyday use stuff that I just need to pull, like test leads and stuff, right? That I need to, little adaptery things and other little gadgets that I need to like pull out every day. I wanted a nice shelf in open trays that I just pull out the tray and there it is, right? Yeah. It's just no taking off lids, no doing anything. It's just, so I custom designed these flat pack storage units with these tubs and very nice.
Yeah, it look nice. Yeah.
But I haven't sorted them yet. So yeah.
Well, I mean, that's the thing. Like when you like,
that's like a weekend thing.
Yeah, when you pick up on that, right? You got to like, put on a movie in the background and like, just
you got to put a podcast on in the background, and it's one of those. I don't want to do it during like productive daylight hours kind of thing.
That's right. Yeah.
During work hours. That's kind of like a nighttime or a weekend kind of thing.
No, I was in the exact same spot. Well, not the exact same spot. Obviously, the scale was much different, but like I just moved all my stuff home from my desk at M Hub because I'm just going down to like just the the shared area.
So you're not at M Hub anymore? You're Gonski?
Well, I can go in, but I don't like have all my stuff there anymore. It's like at home now, and
so you don't actually. So you're not paying for a workbench there anymore.
Yeah, I'm not paying for like a permanent bench, but I'm still like paying to access equipment and stuff. Like that.
You're paying for the regular access, the regular pleb access, right?
That's right. Right. Yep. Not non-VIP. I can't actually.
Right.
Yeah, it used to be 24/7 access. Now I have to go in during working hours. Ugh, yuck.
Oh, really? Okay.
Yeah.
Right.
Yeah.
There you go.
Yeah, so I had to make similar decisions, and just I think the forcing function was the same thing. It was like, oh well, end of the month, got to go move all my stuff home, and and refactor then, and
I started my move like 3 months ago. I thought, I better start now, and it was still a last minute scramble.
Yeah,
it was literally 11th hour stuff. Like I was going to dump a whole bunch of stuff, and then people turned up at like with hours to spare. Nice. But before it was going to be tossed, and I didn't toss anything really. Everything was taken. So yeah.
That's always a tough thing too, like the sorting process and just like the some days of it. I just luckily I've had some stuff laying around long enough. I'm like, stuff that was like cluttering up my bench in Cleveland. I think it's time to get rid of that.
You're right. How many years ago was Cleveland?
Yeah, that was 4.5 years ago. So yeah.
Oh, that's that all. Okay.
Yeah. Yeah, but the big thing for me is like, I think some of it is also just like mentally, like I'm like, Chris, it's okay to leave some space unused. It will get used eventually. You know?
Yeah, right.
Yeah.
Oh boy. Yep. All right, let's get on to our list. Can we talk about this, because it's one of these things that, is like, I'm glad the service is available, but then again, I don't kind of understand where it fits into the scheme of things. It's very niche. Anyway,
I know what he's going to talk
SparkFun.
about here. Yeah, yeah,
Yeah,
exactly.
SparkFun a la carte, they call it. A la carte. And it's a...
Dave, your French is impeccable.
Here's the blurb at the... Point and click your way to a fully populated custom printed circuit board from SparkFun. Click here to get started now. It's like, so they will actually design your board for you.
Yep.
Am I right? Because
it's
kind of, sorta.
Yeah. So there's another. So like basically, it's they have all of their stuff as modules in a CAD program. I think they use Eagle still, and basically, I think it's like you're using. It's almost like a selector. It's like a pull down program effectively, and like there's however many branching options there are. It is a reasonable amount of things that can be hooked from one to another, and basically you're selecting all of the things that can be selected, and then it's going to auto place those, and off you go. So basically, it's like kind of, SparkFun obviously sells a lot of great modules. They're kind of small breakouts for chips and things like that. The way I kind of think about it is like they have these boards, and they're just kind of putting them all onto one board for you. And that's kind of the main thing.
Yeah. Somebody mentioned this. It's kind of like for somebody who designs a gadget for Burning Man, and they don't really know anything about electronics, but they need like 20 of them, and they don't want to hand wire 20 of them, and that's kind of the market for it, and that's about the only market for it, perhaps. I'm exaggerating there a tad, but it's not a big market. Right?
Yeah, I think it's all low, it's all low frequency, low power signals, right? So like from that side of things, it's stuff that would be just as good if you did wired point to point or through a breadboard or whatever. Like it's not like you're, I don't think any of the modules are going to be anything high speed other than, maybe, I know one of the modules you can put on there is like a ESP. So like, yeah, that's got RF subsections on the chipset or on the module, but that's not dependent on how it's laid out.
Yep. Can you like define the size of the board, the footprint? Because like this is not a fully custom PCB design service. They are not going to design a fit to envelope PCB for your, fancy looking, smart watch for Kickstarter or something, right? That's not what this is.
Right. I agree. Yeah. I think that, you have to go to a consultant,
a real PCB designer to do this.
Exactly,
and it's, what is it, $995 or something?
Yeah, so half off for the first year, I think, or to the end of the year. Right. So, but yeah, that's
to some, that sounds cheap. To people who know about this sort of stuff, yeah, if you hire a professional PCB designer, $995 is cheap, right? Yeah. But to others, it might seem, so expensive,
Yeah. I think if you took, so I think it really comes down to like activation energy, right? So like, if someone is used to buying from SparkFun and they're buying modules and they like it, they're able to hook things up and they're like, oh, look, an option to just move forward. And like you said, build 20 of a thing. And like building 20 hand-wired prototypes is not trivial. That's, like a lot of things can go wrong with that. Yeah. So like from that perspective, that's great. And I think that that's actually a great use case for the service. I think if that same person knew a little bit more about what the potential output was, they would just as easily be like, I'm using these 6 modules from SparkFun. They'd go on Upwork or similar and be like, hey, can you take these files and mush them all on a board with this form factor? And like, it would probably be about the cost of this. But then, SparkFun's going to make this board for them too. So like, there are benefits to this.
Is that included in the cost? Is making the board included in the cost, or
no?
It's just the layout. This is just.
I think the board might be. I don't know if there's a flat charge for the board. That might be included.
Because boards are dirt cheap these days.
Yeah, exactly. And I think there's a price when you go through the actual menus. There's like prices on each module, and it's a little bit less, I think, than the actual module itself that it would buy. So I'm not completely sure on that. I've gone through it like once. So
yeah, I haven't even gone through it. So
yeah, it's worth going through it. I think it's interesting.
All right.
What someone brings up in the subreddit comments is something that my friend Yoris had told me about it recently. But Gumsticks has a very advanced module. It's called Geppetto. So geppetto.gumsticks.com is like a competitor, I guess. But so I had heard about this because they already have like Raspberry Pi 4, the CM4, like we talked about, I think 2 weeks ago, the module, and then we talked about it last week with Jay as well. And it's like basically breakout boards for something like this, and it's kind of reconfigurable. It's got some 3D elements to it, and like basically you see everything. Like this is a much more advanced version of the same kind of idea. So if you're building stuff and you're not using Raspberry Pi, or sorry, you're not using SparkFun things, then this might be a good option too. So if you're in that builder section of things. Of course, Chris is going to suggest that you should learn KiCad. You know, that would obviously be the best solution, but
KiCad.
You know, that's whatever. And that is, I think, the best solution. But that's actually pretty big.
Some people just don't want to. Like, exactly. It costs you more than $1,000. If your time's valuable, it costs you more than $1,000 to learn how to use KiCad, right? Maybe. Just in time. Right. Yeah. I'm actually going through this now. I've selected my controller. You're allowed to select one controller, like an Atmel or whatever it is. Then you're allowed to select components. I've selected a couple of switches and things and other modules, and then you can select connectors. And you know, it's pretty limited. I mean, it's, you know, I've only got a couple of types of connectors.
I'm trying not to judge it too much right now. You know what I mean? Like it's a new service.
Yeah, so it's a new service, and they can add things later. You know, you can add if you had 1,000 different types of connectors, you go, okay, this is getting serious, right?
And I think one of the things that they're offering here is there's a limited ecosystem, anyways, right? It's people that are like deep in the SparkFun side of things, and yeah. So probably not most of our audience, but maybe. But if
most of our audience wouldn't.
It would be interesting to
wouldn't have need for this yet, because they'd actually design their own. But no, I'm sure there's a niche for it, but it's not. Yeah, it's not magic. There was quite a bit of hoopla. Oh, look, get a custom PCB design for $995. It's like, not really.
I mean, even if you found someone like in a lower cost country that is doing it for $50, that's like 20 hours.
Oh, you can lay out your board for $50. Yeah.
Sorry, $50 an hour. I meant. Sorry.
Like, $50 an hour.
Yeah, like $50 an hour. Like and there's some places that's going wage, and that's great, and like good engineers that'll do that sort of thing, and it's like, all right, that's 20 hours. Like you could get a pretty good design in 20 hours, I think. So, but again, it's that activation energy. Are you going to go and source that person yourself? Deal with it. What if it goes wrong? Whereas this is probably a known thing.
Yep.
So,
but a lot of people don't know how much time and effort goes into producing a real top quality, complicated PCB for a real product that requires fit to envelope design and stuff like that. You know, I've worked a month on a PCB.
Sure.
Right.
Yeah.
And it's not because I'm slow. Right. It's because there's a multitude of
one component a day, folks. That's all he'll do.
It's like
he's like, no, I'm taking my coffee break. I'm taking my 15.
Anyway.
Yeah.
News. Straight off the teletype from the New York Times in their New York Times font.
Oh.
Can we like yawn? It's like somebody's buying somebody, but
I don't know what you're talking about here yet, so I'm getting there.
This is pretty big. AMD agrees to buy Xilinx for $35 billion in stock.
Boring.
Is there anyone left?
I know, right?
To buy? I mean, who bought the Altera? The
Intel
IBM.
Altera, yeah.
Who the hell bought Altera?
Intel.
That's it. Yeah. Intel bought Altera.
You may have heard of them.
AMD. Yeah. I just, and now AMD buys Xilinx, of course.
Yeah. Yeah. Pepsi battles Coke. Xilinx battles Altera. And
Intel battles AMD. It's like, okay.
RC Cola is over in the corner, just crying.
Who bought ARM?
RC Cola, do you know?
No, RC, no idea about RC Cola.
Royal Crown.
No,
that is SoftBank had bought ARM previously, and then they sold it recently to NVIDIA.
NVIDIA, that's it. NVIDIA. Yep, that's right. It's just I can't keep up. We haven't been able to keep up for the last decade. Let's admit it.
Yeah, I mean these. I think you're right though. It is kind of it's big fish eating bigger fish. Well, not bigger fish eating big fish because all the small fish have already been eaten.
Yep.
So.
Oh boy. Anyway,
I don't think this impacts us. I mean, I don't use any Altera parts anyway,
it doesn't change. If you're a Xilinx fanboy and you use Xilinx every day, it's not going to change.
Right.
Anything really. unless they get in there and sharpen their pencils and parts get deprecated and
well, yeah, it could
stuff
be.
like that.
I don't.
But they've got to honor existing contracts, so it's not like, you buy, AMD buys Xilinx, and then Xilinx originally had a 10-year contract to supply this part to some military vendor. It's not like AMD can go, oh, sorry. No, you buy the baggage that comes with that.
That's right. That's right.
So,
yeah, I wonder about the emotional toll, not the emotional toll, but like so like I remember like people talking about
emotional toll on the Xilinx fanboys.
Well, yeah, I mean, like, so I remember like I think when I was a Keithley, like one of the guys told me like, oh, it'll always be Burr Brown to me, like the TI.
Yeah,
it may be TI, or maybe it was you talking about. I don't know, someone talking about that.
Yeah, I was a Burr Brown fanboy. Yeah,
of course, yeah, they're great parts, right? But like, I never really felt that, and then like now Linear Tech is a analog devices company. Well,
yep,
and like, but like it's just the thing, and then you kind of get, you get attached to it. That's really I think that's the only thing that really impacts me is like, yeah, if they start, like, so like Altera is, Altera is now Intel FPGA, right? So like, or Altera Intel FPGA or whatever it is.
Yeah, they actually, yes. I don't think, did they drop the name entirely, or they're in the process of dropping the name?
I think they're well on the way to just being Intel.
Right.
I mean, and if you think about it, like, it makes sense from a brand perspective of like, Intel's a pretty strong brand.
Oh yeah, and whatever happened?
Oh yeah, here we go. Intel.com.
Atmel. Oh yeah. Whatever happened to Atmel? Are they still Atmel, or are they trying to rebrand a Microchip parts? Because that's been a couple of years now, hasn't it?
I think so. The easy way to do it is you just search on the terms here. So I just search for Atmel and microchip.com pops up. So there is no Atmel.com anymore. It's just going to be,
right.
It's just, so like that is the modern day equivalent of how.
Are they still branding, I mean, the part number is going to be the same. It's still AT, right?
And that's usually what survives. Yeah, I mean that's how you can tell the old.
That's usually the only thing that
TI
survives
parts,
the
like
number.
the BQ family and the Burr Brown stuff, and
yeah, exactly.
Yeah.
So all of that survives. So the Nat semis and the.
Yeah, exactly. Yep.
Yeah.
Yeah. That was LM, right? That was National Semiconductor, LM something.
Yes, LM. Yep.
Yeah. But I think eventually they're all just going to get subsumed by the main brand and corporate silliness.
Yep.
Oh, to be in a big corporation again.
So if I go under Microchip here, I'd be surprised to actually see the Atmel name now. Product offerings.
There's Atmel Start, but that's because I think that's the actual tool. That's like what comes up. But yeah, I think it's all becoming one chip. It's going to be really interesting, David. What are we going to talk about 10 years when it's just like, hey, did you see the new part from Chip Company?
Yeah, exactly. Oh, here we go. I've got it. It's just PIC and AVR. There's no mention of Atmel. It's just they're AVR parts. So there's the PIC line and there's the AVR line of Microchip parts.
Yeah.
So I think that's how they've done it. So which is smart, of course. You have to, because that's what people. Oh, it's an AVR processor. It's the AVR architecture. It's like you can't just suddenly go, oh, it's a PIC, because a PIC is a different architecture to an AVR. It's
yeah.
So, yep. Oh boy, the worlds are changing, my friend.
Oh, don't I know it, man?
We've been doing this shit for too long. It's like,
well, we have been. Yeah, it's been a while. So to give an update on a long ago thing. So I'm going to be working from another location in a couple days, and you remember the Porta Lab? Porta Lab never really made it off the ground.
Yes. Yeah.
But I do have like a subset of different things I take with me now, and like so I have a pretty good setup that I take with me, that I'm going to be taking with me on this short trip. It's like J-Link programmers and, the TS80.
Is this for a client thing? Is this a client road trip?
It's like an on-site thing I have to do. And, but like having like all the measurement equipment, it's just kind of all shrunk down. And I just really like that trend. And I kind of hope that that continues. Because
are you taking a real scope? Is there a real scope in there, or you're
no? Well, it's going to be Analog Discovery, but I really like those. So. I mean, and like most of the things
not a
I'm
real
doing,
scope. You know what I meant by real scope.
Yeah, I mean, there's no knobs. It's no built-in screen or anything like that. I think it's it's definitely a PC scope, and it's low 30 megahertz. But like for what I do, it's fine. How would you define a real scope?
A real scope is one that sits on your bench. Yeah, it's form factor. It sits on your bench,
Yeah.
It's a square, it's a rectangular box, and it has a big screen, and it has knobs and buttons, and, I would even go I don't know if I'd use the word real, but it may be differentiated between bench scope and PC scope. A bench scope, because you can get bench ones that are, that are all touchy-feely, It's like the new tech one, right, is all, it's mostly touchy-feely.
Oh, you mean it's like touch interface, you're saying? Yeah.
Yeah. So there's, you can get more of that and less knobs.
I have an interesting requirement where I actually really like PC scopes and PC-based microscopes as well. It's kind of weird. So I use this program called Manic Time, which I don't think I've mentioned on here, but I kind of love it. I installed spyware on my computer for myself. Yeah. And it takes a screenshot every 30 seconds now. And it tracks hey, are you looking at a browser? Are you looking at a whatever else? And so I use it for consulting, obviously, to track my time and things like that. It's really, really useful, to the point where even I could not remember what I had done in a Linux terminal. I'd been typing commands in, and I was able to go back to that day 8 days ago and go to the time where it happened, handy. And I could see a screenshot of the code I pulled up, or the code I typed in. So that was kind of crazy. But the nice thing is so now I put my microscope into just on one of my screens, and then I can actually capture I was working on that board, board ABC on that day, and I can actually see oh, that's what I was doing that day or whatever. And so the same thing with scopes, I can go and capture, not that I need that for capturing traces, but just seeing what I'm doing every day. Everything's kind of on the screens.
It's almost like a proof of work. Show me that you could go, well, here's an animation of 30-second screen. Here's a 1 hour animation of 30-second screenshots. Go for your life.
Oh, I have no fear of ever proving my time. I can totally do that for everything I do. And that's not the reason to do it. It's actually, it's really just a great program.
Yeah.
It's interesting because that plays into then having having this kind of microscope versus there's obviously many better ways to do it, but it's a nice silver lining, I think.
That's our amp hour, dude.
Did you end up listening to the last amp hour, or no? Or is that still on your?
No, I haven't listened to it yet. That'll be a. I only put podcasts on. Yeah, that's an organizing lab podcast.
Yeah. It's a good one. I listened back to it just to hear what Jay was talking about. It's on my list of, I think I said on the show, my ever-growing list of things to learn, but building my own Linux system. I'd like to do that within the next year. I think that's doable.
Yep.
Hold me to it, Dave.
Okay.
All right. All right. Well, good luck with your continuing lab organizational tasks.
Yeah, it's good. I handed back my keys the other day, so it's
that's the right
done.
step. Yep.
I'm enjoying saving the money. I can
great.
I can just feel the cash washing over me now. That I was pissing away before.
Can I borrow $20? I hear you're flush right now.
Yankee bucks or
either one's fine. Yeah.
Right. Oh, I got 20 Aussie bucks here.
Oh, well. All right.
Vastly superior to that cotton rubbish that you guys have got.
Yeah, I agree.
All right,
man.
Catch you next time.
You just finished episode 516 of the Amp Hour, courtesy of our patrons. Join the club at patreon.com/the Amp Hour. Or if money ain't your thing, throw us an iTunes review. We love it all. A special thanks today to our corporate sponsor, Benio, who now sell the PC Byte, grippy proby goodness for your bench.